The physical switching side of it is an important component of any data center solution set. So it's important for us to be able to understand how this is going to fit together within a cloud environment. Within the Cloud Fundamentals course, you've talked a lot, you'll hear a lot about all these different core components. It gets down into a lot more detail than we're going to cover here. But I want to make sure you guys at least understood what what these different products do, where they fit, and ultimately how you can integrate them into your cloud platform. So first, we have to look at really the full Nexus data center switching line. So here you're seeing everything on the left from Nexus 1000V up to the Cisco Nexus 2000, which is your fabric extender. You've got the Nexus 3000, you've got the 5000, the 6000, the 7000, then you've got the 9000, which provides you that ACI environment. So each of these switches can be integrated into the solution. The Cisco UCS Director fully supports all of these different platforms. The cool thing about it is when you think about these different solutions, it's not so much that, well, why do you have so many different devices? Well, because each one of them has specific uses and use cases. So the ability to be able to have this level of flexibility is something that is extremely valuable from a portfolio perspective. It's also important to understand that all of these different capabilities that we've got, we have APIs that have been integrated into the vast majority of all these platforms, which means that you have the ability to be able to automate as well as customize and script a lot of the functionality that you would normally have to get onto the device itself and program in either by hand or with other management tools. So it gives you a very nice platform you can use to help to improve your operational model as well as to provide a lot more simplicity into your designs. This is a very high performance set of solutions as well. So we support everything from 1 to 100 gigabit, as well as the ability to be able to scale all of these different platforms. We leverage VXLAN very heavily to be able to do secure segmentation in these platforms, allowing you to be able to then extend and create a, for lack of a better term, a virtual overlay into your network so that you can stitch together many of these different solutions seamlessly. And we'll get into more detail on that here in a second. At this point, let's go ahead and introduce Cisco's ACI. So ACI is a unique capability that Cisco has. The Nexus 9000 series of switches, of which there's two different models. There's the 9500, which is your chassis-based switch, designed more for your spine environment in an ACI solution. And then you have your 9300, which is your top of rack switch, or more of your leaf type of a switch. Now, you can use the 9500 as a spine if you want to, or you can do it as a leaf. It just depends on what cards you put into it. Same thing on the 9300. You've got variants where it can be spine or leaf. That just depends upon the actual chipset that's built into the platform itself. So when you order it either as a spine card or as a leaf card. Again, that's more detail probably than you need at this point, but just understand that these platforms allow you that level of flexibility. You also have, outside of the physical hardware, you've got the application-centric policy. This is really the core of what ACI offers. This gives you the ability to be able to create those custom, solutions and designs within your data center that's really, decoupled from the actual hardware itself. It's stateless environment. That means you don't have to worry about a pre-configured, data center or environment. You basically can apply policy on top of it and instantiate that across the data center. If that sounds a lot like cloud with that common pool of resources, you're absolutely right. That's exactly why it was built that way. In addition, you have a controller concept. Within this platform of ACI, you've got the APIC, or the Application Policy Infrastructure Controller. This is really the brains of the ACI environment. This will actually take all that policy information that you pre-configure and then put that information into the switching fabric itself. The cool thing about this design is, unlike other controller-based technologies and designs, the controller here, the APIC, is not part of the traffic flow. So you don't have any slowdown at all by forcing traffic through some controller to be able to determine where it needs to go in the fabric. All of that's done natively within the hardware itself, which is unique to what we offer with ACI. So one of the core aspects of it as well is we start to dig down into that policy. I mean, this is really where the rubber meets the road from a capabilities perspective. ACI has something called an Application Network Profile, or an ANP. This is a solution that allows you to be able to tie a lot of the core, capabilities that you would normally have to custom configure in your devices, and be able to provide a way to wrap them up into a profile. So you've got things like service level agreement, quality of service, security, load balancing capabilities. If you need firewalling put into this, all of this would be part of that profile. And that profile is then able to be extended into the actual connectivity aspect as well. So being able to drive all these different capabilities as a single component of that profile means you can define it once, create a template, and then deploy it as many times as you want within the fabric of your data center. Again, it makes it super easy. So how does it work? You take that particular profile, you've actually created that concept. So let's take a traditional 3-tier application. So here's an example of kind of how the different application components work together. So on the front end, you've got a firewall and maybe a load balancer to be able to connect to your web portal or your presentation layer of your application itself. Behind that, you've got another load balancer to be able to load balance the load to the actual application intelligence itself. And then behind that, you've got a database server. So these are this is your typical 3-tier application. Each one of these would require, in the old way, you'd have to pretty much provision all these, either manually or you'd have to do it, in a very rigid format. Within this type of solution set, all of these configurations are then added into that profile. So the way this stuff is integrated together, the web, the app, and the database, all the different services that are tied to it, firewalling and load balancing, that's all stored within that profile. And once it is stored within that profile, the profile is then sent into the fabric. So here we're going to load it into the APIC, into the controller, and then that profile is now available across my entire data center fabric. So regardless of where the actual workload sits, and this is a very important part, it doesn't matter if it's in VMware, it doesn't matter if it's in Microsoft or Red Hat. Those are very disparate and different domains from a virtual machine management perspective. Well, if I'm in an environment and I want to move a virtual machine from VMware into Microsoft, those two don't really work well together. It's not designed to be able to make that very transparent. With this solution, however, I can easily do that because the policy is not dependent upon the end state, and it's not dependent on where the virtual machine sits. So if I need to move something, I just move that particular application, and I can move that virtual machine between any one of those, and the policy follows it. That's the power of what we offer with ACI. In addition, that ability to be able to do that infrastructure automation. So we talked about ACI, we've talked about some of the capabilities that we have from a traditional Nexus platform with the APIs to be able to control it. That's where we start getting into that infrastructure automation capability. So here's an example of how we can drive that functionality using UCS Director. So as we mentioned before, UCS Director does compute, network, and storage. It does the automation of all those infrastructure components. By being able to leverage the capabilities in something like ACI or in our traditional Nexus line, we can also automate the functionality of really driving the security and the integration of firewalling and load balancing and all those kind of things together, making it very simple to be able to create templates that can be deployed across our entire data center. So it provides not only support for automating the infrastructure of a virtual environment, which is arguably the easiest way of doing it, we also can do it with a physical environment as well. And let's be realistic. If you walk in your data center, it's not all a bunch of virtual machines. The reality is there's a lot of blinking lights in there, and those are plugged into something. There's a lot of physical pieces of hardware. It leverages this wizard-driven deployment as well, so you can integrate this into your compute environment, as well as the ability to be able to integrate it, again, via those APIs we talked about, into directly into the infrastructure hardware itself, as well as being able to control the system northbound as well, which means that things like Prime Services Catalog, you can have that control UCS Director. So that's what we're talking about, that northbound REST interface. So this gives you an example and hopefully helps you to understand why it's important from an infrastructure perspective and why you would need physical switching to be able to support some of these capabilities and really what UCS Director can do to help to automate the provisioning of your infrastructure.